Okay, sorry about that, guys. My battery died again, so I had to make a quick change. But here we are using our slope-intercept form, okay, our y equals mx plus b form, to write two equations, one to represent Hannah's speed and one to represent her mother's speed. Okay, so let's start here. Hannah's mother, y equals, and the rate is represented as slope. So she's going 13 miles an hour. Okay, so there's her rate, 13 miles an hour. Hannah leaves, oh, so that's where, I see. Hannah leaves the house after her mother has biked 2 miles. Okay, so here's Hannah's mother, right? This is Hannah's mom. She's going 13 miles an hour, and she's 2 miles ahead of Hannah. She's already biked 2 miles, and she's going 13 miles an hour. Now, Hannah, on the other hand, is traveling at a speed of 17 miles per hour. And she's starting at 0, right? Mom's 2 miles ahead. Hannah's going to try to catch up by riding 17 miles an hour. The question is, will she catch up with her mother? And if yes, when? Because both of these are in the form y equals, we know that they equal each other. So let's see if we set them equal to each other, what we get as a solution. Okay, so if y equals both of these things, then they should equal each other. Okay, let's move this 13x so by subtracting it from both sides, and I end up with 2 equals 4x, because 17 minus 13 is 4. I'm going to divide by 4, and I'm going to get 1/2 equals x. 1/2 of what? Okay, 1/2 of what? And the answer is, this is the amount of time that they've been riding, right? This is 13 miles per hour, so half of an hour. Okay, x equals half an hour, essentially 30 minutes. Okay, so after 30 minutes, Hannah is going to, so if she catches up, when, she's going to catch up in 30 minutes. Now, at what point, it doesn't say necessarily if yes, where, but we could solve that also, because we know when, we know she's going to catch up with her, right, at 30 minutes. So if we put that 30 minutes in, which we're not going to put in a 30, we're going to put in 1/2, because that's what we got here. We're working in terms of hours. If we put it back into that original equation, 13 times 1/2 plus 2, okay, then we would know that Hannah is going to catch her mother here at 6.5 miles. Okay, just check that, make sure. 6.5 miles is when she will catch her mom. All right, now I want you guys to see something before I turn you loose here to move on to the practice. I would be remiss if I didn't show you what Mrs. Fairbank made, because I just think these things are so cute. Look at this, guys. Okay, so she drew these little papers here to show these 3 different types of systems that we've just learned. Again, not in concept, but just in name. We already know what they are, but now we know how to name them. That when there's exactly one solution, that we have a consistent, independent system. And the way Mrs. Fairbank designed these is she designed them so that when you open it, you can see here, she's got an example of 2 equations. She solved it, and they have a single answer. So that's pretty cool. She did the same thing for this consistent dependent system here to show that when these equations are rearranged, we see that they end up being the exact same equation, which means they have an infinite set of solutions, infinite number of ordered pairs. In essence, they are the same line. Okay, so that's the consistent dependent system. And then our final type of system here is the inconsistent system, where we have the same slope but a different y-intercept. And the same thing, guys, she drew the whole thing out, used the example that we used here in class today to show that there is no solution. This is an inconsistent system, and we see it in the graph. in the form of parallel lines. So I thought that was awesome. And I wanted you to see what she designed there. If that's a help to you and you want to design something similar for your own notes, please feel free to do that. But for today, here for lesson 67, we've got a few lesson practice problems to do. If you have time here in class, I would like for you please to, let's see, I would like for you to try to work your way through A, B, C, and D. Don't worry about that word problem, okay? But make your way through A, B, C, and D. Classify those systems of equations, okay, as either no solution, and so that means that they're parallel lines, they're inconsistent, as infinitely many solutions, meaning that they're consistent and dependent, or they have a single solution, and in that case they would be consistent and independent. All right, we'll take out those whiteboards as long as you've got time left in class. Show those to Mrs. Bryden, and lesson 67 homework is due at our next class period.